This is Josh White with JW Math Tutoring. Today's video is going to cover Digital SAT Practice Test 6 from the Bluebook app, Module 1. So let's go ahead and get started.
But life is a dream the calculus could never predict.
Just before I begin, Digital SAT Practice Test 6, Math section, Module 1, just a couple things to keep in mind. First, I will most likely go over the allotted time for this module because I'm going to show multiple methods to solve a lot of these problems. So just keep that in mind. Obviously, if you were taking this test within the time limits, you probably wouldn't do each question, 2 or 3 different ways. You would most likely do it one way, and maybe you would check it a second way if you had time. All right, in addition to that, of course, if you like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. So with that being said, let's go ahead and get started. Question number 1, we have here a bird that flies at a speed of 16 meters per second. How far does it fly in 4 seconds? Well, we're just going to take 16, multiply it by the 4, and that's going to give us a total distance of 64 meters. So the correct answer for this question is just letter A, and we can move on to the next one. Next, we have a line, and it has a given slope, and it has a given point, and they want to know the equation for this line. So these lines are all in slope-intercept form, y equals mx plus b. We know that its slope is 4. So right off the bat, we can eliminate this, and we can eliminate this. So we're down to these two choices. And we know its y-intercept is 6. So the correct answer is going to be letter D for this one. Note, you could also do this in Desmos. You could go to put in the point, and then you could type in the slope and get the equation, but you should hopefully be able to recognize how to put it into slope-intercept form if you're given the slope and given the y-intercept specifically. All right, next we want to match up some equivalent expressions. So for this one, you are going to basically just factor out a common factor, which is going to be x to the third. So if you go ahead and factor out each term, you're just going to be left with 5x squared minus 6x plus 8. So if we go through the answer choices, okay, it looks like it has to be answer choice B. Notice that you didn't actually even have to do all that work because that's the only one that has the correct common factor of x to the third out front. So you could actually get that just by noticing the common factor is correct in B only, and then just, move on and select the others. Now, I do want to show you one other thing that you can do when you want to match two equivalent expressions. So you can go to Desmos, and basically what you're going to do is graph the original expression. Okay, so here we have the graph that. And then what you would do is you would go through all the answer choices and you would see which one matches, i.e. which graph completely overlaps the graph of the original expression. So you can see here clearly I have the correct answer, okay? Because if I take this off, there's the red underneath it. Same thing. I take this off, there's no on and off, there's no difference. These two are the same. You do any of the other 3 answer choices, you'll see that they're different, okay? So this is an alternate method you can use to match equivalent expressions, graphing them in Desmos and just matching up the graphs. All right, next we have basically a linear kind of interpretation question. So here you're given this equation, and it's basically got the number of minutes of daylight, number of minutes of non-daylight, and they give you the number of minutes of daylight, okay, which is x. So how many minutes of non-daylight are there? Well, it's basically just plugging in 670 plus y equals 1440, and then just solving this for y. So you're just going to get 770, you subtract 670 on both sides. You could also go into Desmos and plug this in. Now, granted, if you use y, it's going to give you a horizontal line all the way up at 770, so you'd have to scroll out a lot to find it. But you could also back solve by plugging in the answer choices here as well. So correct answer is just going to be letter B. All right, next up, problem number 5. So In this problem, it's basically a kind of like proportion problem in that of this sample of 20, 16 of them are in exactly 3 professional development courses. And what you want to do is basically extrapolate that, excuse me, to what would the number be out of 400. So you just set up a basic proportion like this. 16 over 20 equals x over 400. So you could cross multiply and you get 20x is going to equal 6,400. X is just going to equal 320. Note that you could also just do this by back solving, meaning that if you recognize 16 over 20, if you divide that, it should work out to, let's see, it's going to be 4 over 5 or zero point 0.8. So you could then take these answer choices, divide them all by 400 and see which one equals zero point 0.8, and it's going to be 320. So you could back solve this as well. But the correct answer is going to be letter B. All right, next up, question number 6, solving this equation. So you're given an equation and you want to know also which equation has the same solution. Okay, the easiest, quickest way is honestly just to, what they're looking for you to do is to divide both sides by 7, and then you get 2x minus 3 equals 9. So the correct answer for this is going to be letter A. But I will tell you, you could also do this in Desmos. It doesn't take a lot of work, and essentially what you're going to do is kind of like you're kind of like matching the expressions. You know, the thing process I went through a couple questions ago. So essentially, you type in this thing. All right, notice there's a vertical line right here at 6. So now you would go through the answer choices and you would see which one has a vertical line at 6 that overlaps it. Okay, A obviously does. Notice B does not. Okay, this thing is way over here at 29.5. And you could do the same thing with the others. If you look at C, to zoom out, yeah, see this one is going to has a solution of 42, not the same equation, and you could check D as well, but already know it's going to be wrong. So that's how you could match up the given equation to the answer choices again in Desmos. All right, next up we have a question which is just asking you to essentially solve a formula for C. So all you have to do here to solve this for C is just add 7 to both sides. And so we get 25p plus k plus 7. That's it. It's answer choice A. We don't need to do any more work. I will tell you that with formula questions like these, you can also do picking numbers where like you pick values for p and k, and then you would calculate what c has to be, and then you would go through and like basically plug those in and see which answer choice gives the same value as what you get when you evaluate the original formula. But there's no need to do all that because it's literally just one step, just adding 7. Like on more advanced problems, I will go through that, but there's no reason to waste time doing that on a problem like this. All right, next up, question number 8. We're asked about basically an exponential function where we have 2,000 animals to start with, and it's increasing 3% basically each year. So if you're familiar with exponential functions, hopefully you recognize that the starting amount, the 2,000, is going to go in front. Okay. Now all these answers down here have 2,000 in front, so that doesn't help us. So we have to look at the other piece of information, the increase by 3% per year. Exponential functions are basically set up as like 1 plus or minus r, where r is either the growth rate or the decay rate or decline rate. So here, r is the 3%, or as a decimal, 0.03. So 1, and since this is increasing, it would be 1 plus 0.03 or 1.03. That's the number in the parentheses. So the correct answer is going to be letter C. Again, for this one, you could also do this by picking numbers where you could say, okay, I start with 2,000. How much is it after a 3% increase? What does that work out to? So you go through and you do 0.03 times 2,000. So I'll just go through this one real quickly. So it's 2,000 plus 0.03 times 2,000, and when you do that, the overall increase comes to 2,060, right? Now, What you would then do, and that's after 1 year. So then what you would do is you go through all the answer choices, you plug in one for x, and you calculate all these out, and you see which of these equals 2060. You know, A is going to be 6,000, B is going to be 3940, C is going to be 2060, and D is going to be 1940. So again, it would just verify that C is the correct answer. All right, so here we have, again, a question that's dealing with equivalent expressions. So kind of the, I don't know, traditional way or straightforward way to solve this is you're going to go ahead and just, FOIL out x squared plus 11 times x squared plus 11. That's going to be x to the fourth. The inner and outer terms are going to be the same, so I'm just going to combine them. It's 11x squared and 11x squared just together is 22x squared. Then 11 times 11 is 121. And then for here, this is just the difference of squares. I know that it's going to be x squared minus 25, but if you want to write the whole thing out and do minus 5x plus 5x for the inner and outer terms, that's fine. I can already see that they're going to cancel. So now we're just going to combine our like terms. X to the fourth, okay, that's gone. 22x squared plus x squared, okay, plus 23x squared. So far, these two are gone. And now 121 minus 25, okay, obviously that's going to be closer to 96 than negative 14. So the correct answer here is going to be letter B. I will also show you though, again, you could do this problem entirely in Desmos. So you would just type the first expression. Okay, zoom out. It's a little difficult. I mean, the thing is, it's way up here once you look at the graph. And I'm not going to bother typing them all out, but I will just show you that the second one, this one overlaps it completely. So I take this off and it's directly underneath it. I take this off, there's no change. Obviously, if you check the first one, notice they're pretty close, but actually no, not quite. Because the first one goes way down here. So it's obviously not the same function. And then if you change this to 12, but this to plus 121, again, they're not the same function. Same thing is going to be true for D. So again, you can match these equivalent expressions in Desmos. All right, next up we have the first student-produced response, question number 10. So you're given this quadratic function about the height of this egg above ground, and they want to know the height that it was thrown from. So the starting or the initial height is basically going to be the height when the time, or t, equals 0. So you just plug in 0 for t. This all turns to 0, this all turns to 0, and it's just automatically 18. Okay? And just as a shortcut, that's going to be true for any quadratic function. The initial height is always just the number, the constant you see added at the end, with no variable attached to it. All right, next up, we have an equation here, but they want to know what 6x is, not what x is. So, multiple ways you could do this, although they're relatively similar. First thing I would probably do is divide by 4 to get root 2x equal to 4. Then I would square both sides, and that would give me 2x equals 16. And now, okay, so if you want to find 6x, technically what you do is you would multiply both sides by 3, and the answer is going to be B, 48. But I think what most people would do is instead, you would just divide here by 2. You would say x equals 8, and then, okay, 6x equals 6 times 8, 48. So whichever way you want to do for the last step or two is fine. Correct answer is going to be 48. I do want to show you, though, again, this equation can be solved entirely in Desmos. All right, so here is my graph. Now, let me just zoom in. Let me go to default view. Okay. So notice, because of the square root, it doesn't let me click on the value. So it looks like it's 8, but we don't know that for sure. Here's how you can get around that. Here's how you can tell for sure that it is 8. You can either graph y equals the left side. This is an alternate way to solve equations, by the way. You graph y equals left side, you graph y equals right side, and then you look for the intersection. So let me turn this off. Now it lets me click on the intersection, and now I know for a fact x is 8. Okay, so that's one way to do it. And then If you know x is 8, well, it's just 6 times that. Now, an alternate way you could do it too is you can take this original equation and you can do it as a regression. So I put in a tilde for the equal sign and I change x to x1, and now it returns the actual exact value as a decimal right here. So I'm not looking at a graph, I'm looking at this right here. X1 is 8. So that's an alternate way to do it as well if you don't want to retype y equals left side, y equals right side. All right, next up, question number 12. Here we have basically a description of a linear function. Essentially, you're translating this text into the equation that it corresponds to. So what it says here is for every increase in the value of x by 1, the value of y increases by 8. So in other words, like the change in y is 8, positive 8, because it's an increase, and the change in x is 1, and positive 1. So this is just the slope. Change in y over change in x, that's just what your slope is. So the slope of this line is 8. That means right away it has to be answer choice C. We don't even need to worry about finding the value of b because none of the other equations have 8 as a slope. I will tell you though that since they give you this point here, 2 comma 18, the way you would find the b value is you would basically plug in 18 for the y, and you would plug in 2 for the x into y equals mx plus b, and 18 equals 16 plus b. B has to equal 2. That just confirms the correct answer is 8x plus 2. Also, once you get the slope, I'll just show you real quick. Once you get the slope, once you get the y-intercept, or the you take the point, and you could get the y-intercept value just here in Desmos, put the point in the table, type in a linear regression for the line. We know the slope is 8, so we plug that in, and then it just tells me that b is 2. So that just confirms the equation is y equals 8x plus 2. All right, next up, number 13. So the answer to this question is going to be D. There are 0 real solutions. Now, hopefully you know that because you see the way to solve this is to square root both sides, and on the right side you have the square root of a negative number, which is not a real number. It's a complex number or an imaginary number, however you want to think about it. However, if you didn't know that, you could also get this in Desmos, and there's multiple ways that you could do it. So, first way would be, here's the thing. So you could graph this, and you would notice that even if we zoom way out here, notice there are no vertical lines. Now, technically, that also happens in the infinite solution case as well. I mean, I know this is not infinite solutions, but since it's an answer choice, okay, let's not rely on that. Let's try graphing y equals x squared, y equals left side, and y equals right side, and see, are there any intersections? The number of intersections is equal to the number of solutions, or number of real solutions. There are no intersections, so that just confirms that it's, again, answer choice D, it's 0. Or an alternate way you could do it is you could get it equal to 0, so we could graph y equals x squared, move the negative 841 over, and now you're looking for the number of x-intercepts, okay? So there are no x-intercepts, so that means there are no real solutions. So that's how you could just identify that answer in Desmos. All right, next up for number 14, we have a box plot. And this one's asking for the positive difference between the ranges for these two classes. So class A, notice it goes from 0 to 5. So the range for this is going to be 5. For class B, looks like its low value, min value is 1, its max value is 10, so its range is going to be 9. So the positive difference is just going to be 9 minus 5, or 4. Correct answer to this problem is just 4. Next up, number 15, you're given the edge of a right square prism, the length of it, and you're given the volume and they want to know the height. So basically, essentially we have a square here, and then we extend it up. Okay, since it's a square, we know this is 6 and we know this is 6. This height, we don't know. However, we do know the volume, which is 2880. Hopefully you know the formula for volume of a rectangular prism. If not, it is on the reference sheet. Just to confirm that, you can click the reference sheet. It's right here. Volume equals length times width times height. So let's close that. So this 2880 is just equal to 6 times 6 times the height. Okay, so you go ahead and solve this out. The height is just going to equal 80. Basically 2880 divided by 36. So correct answer for this one is just letter D, and there's no more work to do. All right, next up, 16, we have an exponential function here. Now, there's two ways you could do this. First, if you are familiar with the properties of exponential functions, you know that because this is decreasing, the b value here has to be less than 1. If the b value was more than 1, then it would be an increasing thing, be going up like that. Okay? But that's not what we have. So, therefore, the only possible answer choice that meets these conditions is letter A. Okay? So, correct answer has to be letter A, and you can move on. Now, an alternate way to do this is to go into Desmos and just do a quadratic regression, and then it'll give us an answer that A is going to be closest to A. Everything else, is not going to make any sense. So what I mean by that is I'm going to pick some points from this graph. Let's see here. So like right here, it looks like I have one at 550. So let's go ahead and put that one in. And let me see, where is another point that like it looks like it's right on a nice integer value. Maybe like right here 1020. It looks like it's right on the intersection of the two grid marks. And now I can just do an exponential regression, a, b to the x, technically x1, but so here it gives me values for a, it gives me values for b. Okay, so the b value is 0.832553, it's very close to 0.83. It's nowhere close to any of the other answer choices. So again, you can go to Desmos, you can do an exponential regression. This is going to be just an alternate way you could solve this question. All right, next up, we have question number 17. For this one, they want to know what is the value of cosine x. So this question is actually not very difficult at all because for this angle right here, the cosine is just equal to the adjacent side over the hypotenuse. So this answer is just 11 over 28, and that's it. You don't have to find any other angles or any other side lengths or anything else just to calculate this. Note you could also technically enter the equivalent decimal form, which is 0.3929 or 0.3928 if you truncate, 0.3929 if you round. So those would be acceptable correct answers as well. All right, next up we have an equation right here, and it's asking for the positive solution to it. Hopefully you recognize this equation, since it's already factored and already equal to 0, it's going to have 3 solutions, and they're just going to be basically -2. You said x plus 2 equal to 0, and then subtract 2. This one's going to be +5. This one's going to be -9. Which one is the positive solution? Well, obviously 5. The other two are negative numbers, so just get rid of them. Correct answer is going to be C. If you were having trouble with this question, of course, you could just go to Desmos and you could graph it out. Okay, so notice there's 3 vertical lines indicating 3 solutions. Which one is the positive one? Well, obviously, +5 over here. The other two are negative values, so we're just, they're not the correct answer to the question. All right, for number 19, here we have 2 triangles, and they give us some information. Let's see, we know that YQ is 63. So this side right here, 63. WQ right here is 70. WX over here is 60, and XQ is 120. Okay, what is the length of YZ? So it turns out these two triangles will be similar. The reason why is because they have two pairs of congruent angles. The first pair is these up here, which are each A. The second pair are going to be the vertical angles here, WQX and Y. I'll put two markings just to show that they're not the same measure as the A angles, and YQZ. So by the AA similarity postulate, these two triangles are similar. What that tells us is that their sides will all be proportional. So notice YZ right here is going to correspond to WX, okay? So I'm going to put the 60, which is WX on top, and YZ, which is the side over here, and this one on the bottom. And then I'll do the same thing with two other corresponding sides, like the 70 and the 63. So 70 is from the triangle on the left, 63 is on the triangle on the right, that one goes on the bottom. Now you just go ahead and cross multiply, so you basically get 70YZ equal to, let's see here, 37, can't read my handwriting, I think it's 3780, it's whatever 60 times 63 is. And then when you divide that, you get YZ is going to be equal to 54. So correct answer for this one is 54. Not really much you can do in Desmos. I mean, obviously, once you set up the equation, you could solve it in Desmos. But in terms of actually knowing how to set it up, this one you have to know about similar triangles and the properties of them. Next up, we have a function which is defined by this equation that's given here with a t in it. And this function passes through a point, and we want to know what the value of g of 0 is equal to. Okay, so a couple different ways you could do this. First, I'll show you the traditional way, and then I'll show you the Desmos way. So the first thing we know is that it goes through the point 24, 0. So that means I can plug in 0 for g of x. I can plug in 24 for x, and that will help me solve for t. Okay, notice this becomes 38, but that really doesn't matter because in order for the whole right side to equal 0, this expression right here must equal 0. Because the only way 38 times something equals 0 is if it's being multiplied by 0. So essentially, t minus 24 equals 0, or in other words, t has to equal 24. So what that tells me is the function I actually have is x plus 14 times 24 minus x. So what's g of 0 here? Well, just plug in 0 and, calculate it out. So 0 plus 14 is 14. 24 minus 0 is just 24. 14 times 24 is 336. That's the correct answer. That's what we would type in. And so that's the first method. Here's how you could solve this entirely in Desmos. So we bring up the calculator. Okay, so all I'm going to do is use Desmos to find t. And the way I'm going to do that is I'm going to put the point that I have into a table. And then I'm going to do, technically it's a quadratic regression. I'm just going to type exactly what I have here. Oh, it needs to be x1, x1, okay. So this just tells me, spits out to me, okay, t has to be 24. All right. So now you could zoom all the way out and you could see, okay, when x is 0, where's the y-intercept? Well, it's up here at 336. If you don't want to do that, you could just type g of x equals x plus 14, 24 minus x, and then you could do g of 0 down in the next line, 336, and you could just get it that way as well. Okay, so that's how you could do the entire problem again in Desmos. All right, here we have a problem that deals with percentages. It's actually not that difficult a problem. So if the number of zebras in 2018 was 1.27 times the number in 2014, then the number of zebras in 2014 is p% of the number in 2018. What's the value of p? So basically, think about it like this way. 2018 equals 1.27 times whatever the number was in 2014. All you're doing is you're taking this equation and rearranging it to now that it's 2014 equals everything else on the other side. So you divide by 1.27 and you basically have the 2014 number is, and I'm going to separate this out, it's like 1 over 1.27 times the 2018 number. So now this part on the left matches this is the P percent of 2018. So you just do 1 divided by 1.27. That comes out to 0.787, or as a percentage, it's 78.7%. But notice in the problem they say here, to the nearest whole number. So that means they want it as 79%. So the correct answer for this is just 79. That's what you would put in. Now, I will show you an alternate way to think about this is to do picking numbers and say, okay, 2014, let's say you had 100 zebras. 2018, you have 1.27 times that. Okay, so you had 127 zebras. Okay, now the number of zebras in 2014, which is 100, equals P percent of multiplication the number you had in 2018. So the way you solve this for the P is you divide both sides by 127. So again, I get the same value that I got the first way I did it. 100 divided by 127 is 0.787 or 78.7%. But again, rounded to the nearest whole number, it's 79%. So this is how you could do it with actual numbers. The strategy is picking numbers and, just get it that way. All right, last question on Module 1, Digital SAT Bluebook, practice test number 6. Here we have a circle. It's shown. We're going to have now we have the equation for another circle that we want to find in the answer choices, where we take the original circle, we shift it down 6 units, and we also increase its radius. So a couple things. Radius of this original circle is 3. You can either get that just by counting. Notice, like here's the center, 1, 2, 3. Or you can notice the equation has 9 on the right, and in standard form, it's x minus h squared plus y minus k squared equals r squared. Okay, so the r squared is 9, therefore the square root of that is 3. All right, now circle B is going to have a radius that's 2 times circle A. So that means for circle B, the radius is going to be 3 times 2, which is 6. Therefore, the r squared value for circle B will be 36. So in our answer choices, we're looking for an equation which is equal to 36 on the right side. So, okay, this one's out, this one's out. So I'm down to these two choices. Now, in terms of shifting it, okay, notice the center here is originally at -2, 0. And it shifted down 6 units. So let's count down 1, 2, 3, 4, 5, 6. That means the new center should be at -2, -6. So when you go to plug that in, okay, the first part's obviously still going to say the same, x plus 2. But for the y part, it is going to be now y minus -6. And that just becomes y plus 6. The correct answer for this one is going to be letter A. Couple things to mention. First, a lot of you would look at this and think, oh, if it's shifting down 6 units, we know with a vertical shift, you just do like say -6 to a problem. So therefore, why does it not become y minus 6 squared? The reason is because the y variable is in parentheses, just like the x is. Any variable in a function that you have, which is this is not a function, in an equation that you have, which is inside parentheses, the shifting will be the opposite of what you see. Okay, just like a left or right shift for a quadratic function or a parabola. If you want to shift it left, you do like f of x plus 4 in the parentheses, shifted 4 units to the left. So it's the same thing here. You have to put a minus in here excuse me, this is the wrong one. You have to put a plus in the parentheses to actually represent a shift down 6 units, okay? Now, an alternate way you could solve this, if you really were having difficulty, you weren't sure, is you could just go to Desmos. You could graph out the original problem, and then you could look at the answer choices, and you could see, first of all, are they shifted down 6 units? So let me just zoom back to say, okay, so here is, oh, sorry, that's the answer choice. I want to show, okay, here is the original function. Here's the original graph, okay, that we're given. So now, let's do answer choice A. All right, so first of all, is the radius twice? Well, you can count, here you can see that like, oh, it's at 0, 0, and it's 3 in the first one, obviously. In the second one, you can say, okay, it's at -2, 0 to -2, -12. So it's 12 units across, which means half of that is 6. So the radius is now 6, which is double the original 3. So that part's is met. And now you could also count and say, okay, the center here is at -2, 0. Here, the center, you'd have to do a little work to find. I mean, you know that it's going to be still at -2, but you would just basically find halfway between, 0 and -12, which would be at -6. So yes, it is shifted down 6 units. The others, if you graph them, if you just look at them, so for example, like if I change this to minus, like you can just see it's not shifted down 6 units, right? It's shifted up 6 units, so it's wrong. And the other two choices, B and D, if you just put them in, first of all, like they have 2's in front of them, and they also have a 9 on the right. So the radius is not getting twice as large, even if the shift is correct. I mean, this one it's not, but even if it was, you can see the radius part is wrong. All right, so that was again digital Bluebook digital SAT practice test 6, the math portion, module 1. If you have any questions or comments about this video, please do leave them below. Look out for the solutions to module 2A from the same test, and also module 2B as well. If you like this video, again, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. Otherwise, check out all the other, digital SAT math content that I have out there, including questions from the May exam, questions from June 2024 exam, and other Desmos hacks as well.